Alright guys, so we're going to talk about isotopes next. This is the last lecture for this unit. And at the end of this lecture, we're also going to be talking about, we can stay with red. We're also going to be talking about how to solve the two problem sets that's going to come up. So isotopes. Basically, they're the atoms of the same element that have a different mass. And we've got these three examples. This one is neon 20, this one is neon 21, and this is neon 22. This is how we read it. Even though the number's first, we say the mass at the end. So we write it as neon 20, but the symbolism is 20 in the upper left corner, then the chemical symbol. Again, it's read as neon 20, neon 21, neon 22. And the reason is because these neons have different number of neutrons. So what we have, and we need to let you guys know about this, is that the current hypothesis that the current definition of 1 AMU is 1/12 the mass of a carbon-12 atom. And so we have a mole of carbon-12 is going to actually equal 12 grams. However, the mass of one proton is a little over 1 AMU, 1 Dalton. And we'll talk a little bit about that in chapter 3. And on the periodic table, you see the list of atomic weights on the top or on the bottom of the symbol, and these atomic weights are a weighted average of the different isotopes each element have. And that means we just need to which this weighted average adjust and the average for the contribution of each isotope that it brings. So we're adjusting for the weight, not just the number. So this is, and actually we do this during the grades. Exams are worth 60% of the grade. So if you have one exam, 5 homeworks, 5 daily points, 60% of the grade is due to the exam. You're going to have an exam at 10 points or 100, doesn't matter. That's how we work this. And that's the whole thing about isotopes. Now let's look at the worksheets we're going to have. This is worksheet number 1, and we got all these columns, and we've got the atomic number, the mass number, number of protons, number of neutrons, and number of electrons. You'll be given the nuclide symbol, and you got to give me the hyphenated name. So from here, look, upper left is 7. That is the mass number. Lower left is 3. That is the atomic number. Atomic number and the number of protons, and in this worksheet the number of electrons are the same because all of these are neutral. So for neutral atoms, atomic number is equal to number of protons, and then equal to the number of electrons. It should be real easy. The mass number is protons plus neutrons. So protons plus neutrons gives me a mass number. And then you write the hyphenated name with its lithium and then the mass number. So the name and then the mass. Let's look at this example. This is called Cobalt 59. It has the atomic number is 27. Therefore, the number of protons is 27, and the number of electrons is 27. We have a mass number of 59. And that means 59 minus 27 gives me 32, and that's the number of neutrons. So if I add these two together, it should give me 59. This is how it works. All right, let's look at this nuclei symbol. We have 47 for the atomic number. That gives me the same number of protons and the same number of electrons. 108 is the mass. And 108 minus 47 should give me 61. That's the number of neutrons. This is silver, 47. This is how solving this worksheet works. All right, Isotope Worksheet 2. We have an extra symbol, extra column, it's charged. So let's look at the first one. Plutonium 94. Plutonium 94 is, whoops, not 94, 294 is the atom's name. Mass number is 294. Protons are 94. Now, the charge. If there's nothing here, this is 0. So then the protons equal electrons. If we're going to have something, this is going to be different. We'll do the next example. We'll show you that. 294 minus 94, that means we have 200 neutrons. And there we go. That's how you do the first one. Look at the second one. We have a charge of -1. Remember that this dictates the charge. Mass number is 36. Protons are 17. Since we have a charge of -1, we have 18 electrons. Then 36 minus 17, I believe that's 19 neutrons. Yep. And that's how this works. Mass number minus protons gives me neutrons. So we stick a negative there. So this minus this will give me this. Protons, this minus this should give me a charge. 17 minus 18 is -1. Now what happens if we have a positive one, like we do here? This gives me the charge. Mass number is 24. Protons are 11. That would give me 13 neutrons, I believe. Yep. And now the electrons. We have a positive charge. That means we got one less electron than protons. 11 minus 10 equals +1. There's my 10. And this is how this works. We want you to do both of these worksheets. Now, on you'll get a Google Sheet, and on it, you're going to have this table, or the previous table, assignment 1, and on the right of that will be a grid that will change color if you get the answer right or wrong. If you get the answer right, it will go green. If you get the answer wrong, it will turn red, and you got to figure out how to fix it. If you have trouble with that, let me know, and we can try and fix it, and we'll help you out to figure out how to get the right number. One last thing, test this next week on the Wednesday. Multiple choice, Thursday short answer, take home. If you have any questions, please send me an email.